This is going to be a presentation about 3D printing and the impact it can have in reducing environmental burden. Welcome. I'm kind of a usual suspect here, trying every year to give you some new information about 3D printing. My name is Ali Reza Parandian.
And my name is Sophie Mulson-Kern. I'm from Arkema, a chemical company.
So we will be talking to you about how we can get you from a plant to a product today and what the environmental impact is. The whole logic of the presentation is consistent with our philosophy, empowering brands to be able to make more sustainable choices as they move on. There is no winners or losers here between traditional or modern technology. It's just for us important to give information, enlighten people, create transparency, and make sure that they understand the trade-offs for choosing what they do. Obviously, the starting point is that sustainability is an evergreen issue, and that today, overproduction is the biggest environmental problem of the fashion industry in general. For eyewear, that is, and you all know that, for the manufacturers that manufacture eyewear, 20% stock risk, and also for the opticians, 20 to 30% stock risk. And on top of that, consumers really demand for brands, for retailers, to be environmentally conscious and to reduce environmental burden and waste. So it is in that light that I presented last year the first scientific study on comparing an eyewear production line which produces customized eyewear. So I think it's really important to explain the context. This study was done in a holistic way to understand the sustainability when you compare an additive manufacturing line, 3D printing, with a traditional milling acetate factory. But the context was the orders are going to come in based on different kinds of SKUs, colors, and sizes. Yeah. Well, we did the study to validate the claims of the 3D printing industry that 3D printing is a sustainable technology. Now, we did that with that paper. The paper was accepted last year, has been published. There's been a lot of interest into it. You can go to the Sustainability Journal. It is an open access. You can visit Materialise's website. You can Google it. You can find it. If you don't find it, just make sure you contact me, and I'll be happy to give you a paper. But it's kind of unique in terms of studies that have been done on sustainability because it looks in a holistic way to the topic. It looks at 3 dimensions of economic, environmental, and societal impact and compares it quantitatively for eyewear by actually modeling the 2 technologies together. We found that additive manufacturing, when in any scenario of any volume, yeah, and any variation of customization, we found that in the economical dimension, additive manufacturing has lower inventory cost, and it has a significantly lower lead time to deliver the products to the market. We found that it has a much lower labor intensity because in acetate you have to do quite some manual labor. And in the environmental burden, it has much lower energy usage, yeah? Which was quite surprising to myself. As an additive manufacturing expert, I expected our technology to use more energy. But this was not the case for a customization scenario because the machines are not idle and they're much more energy efficient. I have to say that there is a trade-off. So as soon as the volumes go up and the SKUs get more standardized, a milling approach becomes interesting again. Yeah. So again, we wanted to. I mean, we have proven that fact. We wanted to go back into the realm of additive manufacturing and see, okay, we are already producing for many companies here. More than 70 brands have adopted additive manufacturing over the past 8 years that I've been active here. We have gone from producing several hundreds of frames to today more than 300,000 frames in our factory. And the philosophy of our company is to reduce our environmental burden consistently and to be able to guide people through the choices. And we want to explore those opportunities together with you. Again, it's not about winning or losing. It's about understanding where are the trade-offs between these two. Now, we are today going to talk about a new material that we have introduced into our factory, 100% bio-based material from Arkema, polyamide 11, versus what we also have available, which is polyamide 12, which is a crude oil-based material, basically, which is, 90% of all 3D printed frames are made in that material today. What I think is really important for you guys to understand is that the context of the studies that we have done here is in order to understand how we can reduce greenhouse gas emissions. Because obviously, there are trade-offs that we can make between, land use, water use, and greenhouse emission reductions here. So this is a complex puzzle, and we want to kind of try to help you understand how we tackle this balancing act by first talking about 100% bio-based materials so that you can understand that it's an advanced material, bio-based material, but also a circular concept, yeah? That immediately allows us to communicate with you today based on the LCA study that Arkema, the supplier, has done, but also we, through a third party, have validated that greenhouse emissions, specifically CO2, can be minimized by choosing for that option. And obviously 3D printing in its, as a whole, we can confirm today that is, the SLS technology is not the main consumer of energy and has the highest environmental impact. On the economic side, I will be more talking about what it takes to take a sketch and bring it all the way through a product, and what kind of capabilities additive manufacturing offers you. Most important message that I have is that it's not simple, but for brands, it creates the capability of, instead of 5, 6 to 9 months of development time, reduce that to projects that we have done recently, 2 months of development, yeah? What we will be talking about today is reduction of environmental impact in terms of CO2, but obviously when you compare a bio-based material with a material that is made from crude oil, you have much less impact on land and water when you use crude oil. We want to put that in context. We actually collaborate with a partner that develops sustainable farming programs to reduce the environmental burden. And that's a conscious choice that we're taking to increase the yield, reduce water consumption at the same time, while also contributing to the larger environmental impact in terms of CO2. So I'll give the word to Sophie for a few minutes to explain to you the science behind polyamide 11.
Merci, Alireza. So good morning, everybody. I'm quite proud today to present you the story of Arkema flagship polyamide 11. Polyamide 11 belongs to our product range called ABC materials, so advanced bio-circular material. Just few seconds on the history. Polyamide 11 is quite old guys. It has been developed after the Second World War, where the need in plastic was quite strong. And the French government wanted to go away from the crude oil and dependency of it. So French chemists developed this product from a plant, the castor plant. So it's quite a long story. So we are producing these products since now 75 years, and as a only industrial producer. So now let's move on the A, so advanced materials. So this product is used in quite a bright range of process, from extrusion to film, foam, and in optical, what's interesting is molding and now 3D printings. What makes this material really unique is the bio-based material, recyclable, but without compromising at all the performance and the durability. I belong to the business unit High Performance Polymers, where this product is used. So what's taking care on Arkema? So I'm taking care about the 3D printing. So we develop a powder from this P11, which is used in several processes, for example, in SLS. In SLS, in a 3D printing, the P11 is 100% bio-based. Is quite well known and used for its superior ability for elasticity, ductility, and impact resistance. It meets USP Class 6 requirements, so it can be used in some medical application. And of course, it can be an excellent way processable on the machine. So in terms of performance, what is interesting in optic, you want something elastic and ductile that you can bind and without breaking it. This product is comparing it to the peer, so long chain polyamide, like the polyamide 12. The elongation I break is up to 50%, so is double more elastic and ductile as the P12. In terms of fatigue, you don't want that your temple is breaking by bending in. So we even didn't manage to break the P11, even with notched, after up to 5 million cycles. And also in terms of impact resistance, which makes sense for application like in sport or for kids. So refer to the prize winner of SILMO d'Or for kids eyewear with Odette Lunette, with cadets. So you don't want that your eyewear is breaking just after a few use or when it's fallen on the floor. What is also interesting that you can be used under low temperature, so it can be also used in winter sport on this kind of application. So I just wanted to make a snapshot of what are other applications from this product. So the superior mechanical property and ductility is quite well known and used in 3D printing, especially for protection gear, like a helmet or shin guard for football. And the ductility and you can clip the product, so it's quite well also for winter sport to fix the shoes on the surf, and so on and so on. So there's a lot of application where the product's used. I don't hear you. No, it's just a nice picture. No, it's not. So let's go to the B, bio-based material. So now it's a very nice story. I'm very proud because it's not quite used in a chemistry that you can have such a gift to show the people. So everything starting from a bin, a castor bin, which plant in mainly in Indian. Indian is the 80% suppliers of castor oil in the world. You have also some field in Brazil and South Africa, but the main producer is Indian. So we are working with Indian countries since now 75 years. So we have a long and strong experience working there. So the control of the supply chain is established. Here, the beans will be crushed in India, and they will produce the oil. The oil will be imported to France, where our plant is in Marseille, where we are producing the amino 11. And from this amino 11, it will be transferred to some of our other plants, because Arkema's strategy is to serve the region by the region. So our biggest plant is in Normandy, in Cerquigny, where we are making the polymerization, and we have the polyamide 11. We have also a plant in US and also one in China. So what is the top of that and the real gift? When we are talking about bio plant, we have to be careful, because you shouldn't compete with a field where the people we can grow some crops for the food. So castor plant is a plant who is growing in a very acidic and marginal soils where nothing else can grow. Is quite resistant to drugs. So then the need on water is also not that enormous. So important that there is no competition with food and feed for the animals. There is no deforestation needed to grow the plant. For the farmers, is a cash crop. Everything is used. I mean, the seed will be crushed. From them, you will have 40% of the oil will be completely used from us. And in some cases, also in the cosmetic industry, and 55% remain the cakes. And these cakes will be used as fertilizer, or if you eat it, then it can be also used, it will be depoisoned, and then can be used to feed the animals. So for us as chemical company, is a strong commitment to sustainability, and we are building right now. So we are really believing that there's a future for that. So Arkema made one of the hugest investments in building a plant in Singapore. So it's the biggest biofactory in the world. And the plant will start producing in the coming weeks. So we are quite proud of it. And we also engage ourselves to commit with a more sustainable way to produce than our product. I'm at your disposal for further questions later on. So just a few comparison between castor oil, crude oil. We are talking about linear model and circular model. For the linear model, so crude oil, we are capturing CO2 from a deep, which is trapped in a floor, and to produce the oil. So it's a resource depletion. At the end of the life cycle of the product, the CO2 is rejected in the atmosphere. So you are adding CO2 in the atmosphere. You are increasing the gas emission. What we call the circular resource, the plant is capturing the CO2 from the atmosphere, and then you have the circle of the product. And when the product is coming at the end life, then it's also adding it's going in the atmosphere, but it's not an addition. It's like a zero balance. So there is a lot of points to consider when you are making a LCA analysis of the product. I'm focused here on the carbon CO2 emission because of the circular model from the Rilson. Then you see that Rilson, comparing the P11 with all of these peer, which are used also for similar application, we are starting with the half of emission of CO2 than the other peers. So I'll give you the floor if you want to add a few words on that.
Yeah. So obviously, as a manufacturer, when we want to make a choice of using Rilsan or any other brand of PA11, we do have to study for our own whether the claims are correct or not. We are in the process of finalizing a significantly large LCA on PA12 and PA11 specifically for eyewear production. We're not publishing the results here today because doing a scientific LCA study on the subject appears to be a little bit more difficult than, and there are a lot of complexities involved. What I can verify here today is that when you look at the CO2 emissions, we can verify the claim of 46. It's somewhere between 42 and 46, depending on the post-processing technology you use for eyewear. So that claim we can verify here today. What is a little bit more difficult and what needs to be taken into account is that, okay, obviously I said using a bio-based material compared to a crude oil-based material, you have to consider a burden on land use and water use. But when you ask a third party to do these kind of studies, they use programs that are available to do this kind of LCA studies. And it's kind of tricky because those programs don't really consider then necessarily what kind of land you're using. Is it a land where you have competition with food crop or not? Is there deforestation, yes or not? So I think we are in the process of really collaborating with the supplier to get realistic data on the subject and put it into the program to be able to come out with transparent and good results. The other point is that we choose to collaborate with a company that is conscious of the impact that they are making on the soil. So not only the fact that they don't use a soil which competes, they have a sustainable farming program together with BASF to reduce their environmental burden. And Sophie is going to tell you a little bit about that.
Thank you. So, as I was saying before, we are working with the farmers since 75 years old time. So, but we decided in 2016 to launch an initiative called with our good friend BASF, Giant Agroorganics, which is an oil producer in India, and Solidaridad, which is an association in India. To launch the initiative, Pragati initiative. Pragati in Hindi means progress. So we have some milestone to reach and to support and to make the castor plant growing more sustainable. What does that mean? That means that we are in a way teaching the people, the farmer there, to optimize the way they are, that we can call the good agriculture practice to increase the yield. Just like an example, they used to grow the plant quite narrow, and we have some agriculture engineer, they were there, and they just found out that by makes more space between the plant can grow much more, and you have a better rentability of the plants. So they increase the yield, then they increase their income. How to use more efficiency the water? It's a luck because most of the water is coming from the monsoon. But what happens when when the monsoon is over? So how to irrigate the field in the best way? How to manage the waste there? How to deal with pesticide and so on and so on. And of course, one of the strong focus for us is the respect of human rights, which linked also to kid work. So we are really cautious of that. There is a code that we are following with 76 paths. I just put 11 of them, but and I already talk about it. But every point is controlled. There is audit, and every year we are producing the Pragati impact and results, so it's available if people want to follow the adventure with us. So in Gujarat, 700,000 farmer is not big farmer cooperative. It's a very small farmer. It's family, so it's quite a huge work to go there and educate all the people. So now we are over almost 6,000 farmers who are working and belong to this Pragati initiative. After 5 years, we can also have a very nice byline. Then, like 35% of the yield from this farmer have been increased. 35% of less water have been used. Most of the 94% of the farmers have adopted furrow irrigation. So there is a strong and real improvement of that, and we are really proud of it. So just a few takeaways. If you want to live here, just have in mind. So the renewable feedstocks is a cash crop. Farmer is a main source of a constant income. They can also store the seeds, so they can better control the money and the cost of the cash. It's a kharif crop, so from the monsoon, no food competition, and growing in a marginal soil. So now I arrive into the C, which is also very important. C, circular material. So there is a commitment also from Arkema, what happened with the product at the end of life. In June last year, we acquired an Italian company which is specialized in the recycling from high-performance polymers. And from them, then now we are really proud that to supply the market biosourced material, but also partially recycled product. How this happened? So we collect also in the case of 3D printing waste powder, but also end parts. For example, glasses that the people don't want to wear anymore. And we are recycling them in our plant in Italia. And this product is re-engineered, recompounded, and then recertified. So we are now able to supply partially recycled product.
So, thank you, Sophie. In the LCA that we have been making a comparison between PA11 and PA12, what was quite surprising was that the largest environmental impact of 3D printing, whether it is PA12 or PA11, it's focused on powder production. And so as suppliers and manufacturers, you sit and think together and see how can you reduce that impact significantly higher. And I'm proud to present that both on PA11 and PA12 material, we're collaborating with Arkema to recycle the material waste that we produce. But on top of that, Materialise has created a new 3D printing machine which allows it to be the only company in the world that reuses more than 50% of the powder waste that it produces in the first place, not to have to recycle all of it. So we reuse the material waste immediately after production for prototyping purposes, and between 5 to 10% of that which is left over, both in PA11 and PA12 material, is completely recycled at the plant. Now I have a video. There's not much sound coming out of it. But what you can clearly see is that usually when 3D printing has been performed, a certain refresh rate, almost 50% as a standard in the market, is used. Now that is material waste. Some people recycle that immediately, but Materialise actually is able to reuse that material, which significantly reduces environmental burden as well. The rest of the material is then shipped to Agiplast for full recycling. What we are happy to announce here as well is that we have done tests for PA11 with all the eyewear finishing and the coatings that we do on it. So we are doing a call to action here as well. The frames, we are willing to take back the frames also after life. So even the part of the powder that is used for the product itself, at the end of life, it can be sent back to the retailer or the brand, and we are willing to recycle that material so that we are closing the circle. Okay, I will just continue. So you've heard a lot about PA11. Now, obviously, you want to know what does that mean for eyewear. When we compare PA11 and PA12, they're quite similar in nature. I have to say, it's really important that when you create a new material into your portfolio, you need to explain to people how it works. Obviously, opticians are interested in understanding whether it is as easily adjustable or not. It is perfectly adjustable. In terms of flexibility, it is twice as impact resistant and twice as flexible as PA12 material, which is really a significant improvement when you want to move into, you know, applications that have safety requirements or that have kind of performance requirements like sports applications. And now we won the SILMO d'Or yesterday for the kids frames with Odette Lunette. So the material has to be super durable and resilient. It's lightweight, so the frames that we make are super comfortable to wear, and obviously bio-based. But what is the difference with PA12 material is that you have, due to lack of titanium oxide, you have a slight translucency to the frame, where you can create this differentiation in color, where you can create more pastel colors. You know, until now, in the past, let's say 5-6 years, most of the adoption of 3D printing, and it has been growing with more than 30% every year, every single year, has been more by male users. Now, we see that shift happening in the past 2-3 years because there is a wider range of color available, and PA11 with the more pastel colors, as you can see, is offering a much easier to adopt ranges for. When you want to create a new material, when you want to create a new product from a new material, there are several important stages that you need to go through. And Materialise has put together 3 important stages. First of all, you want to understand the concept of eyewear that you want to develop, and you want to explain whether that concept is printable and what kind of results you get out of the printability. Design for 3D printing is absolutely an important element because you need to take the capability of the technology into mind already in your design process. Why is that important? It's because in the traditional world, materials determine the end functionality of the product by 60%. And it's the manufacturing technology that determines it, the design that determines it by 40%. In additive manufacturing, it's the other way around. Design determines 60% of how the material will perform. So if you make the frame temple a little bit thinner, it will flex double as much. If you make it slightly thicker, it will not flex that much. The impact of design is enormous, and you can create all kinds of differentiations by texturing, because in additive manufacturing, complexity comes for free. You don't pay anything extra the more your frame has open structures, textures, and elements included in it. You need to take all of those concepts, the colors, the hinge cavities, the textures, the surface quality into account in early stages of development in order to be able to create a product that can work. Now, I have another video which I'm not going to show, but the most important takeaway from that video is that today, this process that I showed you has been in such a way perfectionized at Materialise. We have experts that can sit together with your designers, that we can take a design from concept stage to full production, like in tens of thousands within 2 months. And we've proven this several times. And the last one was on a PA11 project together with the world champion of cycling in Belgium, Tom Bonen, and Odette Lunette. a complete Belgian collaboration where we went from, discussing on the SILMO about a product, starting to work on the concept in the new year, launching the product early March when there was the round of Flanders. It's like, this significantly changes the game for product creation, reduces time to market, and allows you to go back because if you receive feedback, you can go back to the market and respond to the demand in a much faster way.
Thank you. My question is, all the materials which we are talking about is P11 in 3D printing, but does all these elements apply also for metal frames, for glasses, or we're talking purely about P11?
So here we're talking about selective laser sintering of plastics and comparing polyamide 12 to polyamide 11. At the beginning of my talk, I started to compare selective laser sintering to milling of acetate, and I did that for PA12. Then I went into the world of additive manufacturing and I said there is a difference between polyamide 12 and polyamide 11. So I'm still saying the trade-offs are between plastics. When you go into metal, you enter into a completely different field. We do a lot of metal projects, but it's mainly very niche, high-end applications where, you need to do a significant amount of artisanal processing to the frames.
In 3D printing?
Yes. So I invite you, our booth is right here. So we have projects with McLaren eyewear, for example. We have projects with Porsche design. These are limited edition products, really high-end, with some artisanal post-processing. This is mainly what is, a growing trend of volume in 3D printing is in PA12 and PA11.
Okay, one more question, please. We talked about several elements related to this industry, but what about cost effective between P11 and P12? Which is more cost effective when it comes to trading and business point?
Yes, so a very good question. Today, and I want to underline the word today, because this is the status quo. If the cost of making PA12 frames is competitive with the acetate industry, When you go to larger volumes, we're not competitive with injection molding, but when you go to customization and lower volumes, we're highly competitive with injection molding because has the startup costs. When we move into PA11, we get an increase of about 20% in prices, And this is the price that we see consumers are willing to pay, brands are willing to pay, and also the retail is supporting that because there is an absolute story which people accept. They want to pay more for a sustainable product. But on top of that, we are selecting PA11 for its performance oftentimes because it has a double the performance of PA12 in some ranges. So it actually doesn't have...
So there are some industrial advantages.
Absolutely.
But when you go for a mass production, P12 is still cheaper.
PA12 is still cheaper. If you're comparing with traditional ways of manufacturing, we are on the same price ranges as acetate. Whether it's lower volume or higher volume doesn't really matter. When you compare PA12 and PA11, PA11 is always 20% more expensive. Now, we are collaborating and working on putting PA11 on larger platforms in Materialise to reduce the price, because to a certain level, the price is dependent in additive manufacturing on material. But to a larger scale, the price is dependent on how large the volume of your chamber is. Because the more frames you can produce at the same time, the lower the cost of making, and so you can win a lot on cost. So we have collaborations at the moment ongoing to reduce costs on PA11, but also on PA12. Yeah.
Thank you.
You're welcome. Yes.
Okay, but a frame without lenses is nothing, right?
Yes.
So what about lenses 3D printing? Because some of you may have seen the machine from Lux Excel company. I think they try to produce 3D printed lenses. But I know from my chemical background that it will never work. But maybe you have some other ideas.
Well, to start, the good news is that there are lenses, so we can put traditional lenses in 3D printed frames, and it works. About 3D printing of lenses, yes, absolutely. Lux Excel, also a Belgian company, is a leader in that domain. And, you know, 3D printing has to be used for a reason. And they're using their technology to create very complex types of lenses. And momentarily, if I'm not wrong, they're very much focused on the smart eyewear field, which is fully up and coming, and where we're highly active in as well. And very happy that Skuga last night, one of our partners, also won a SILMO door. I do have one more slide which I want to show you, and I think that's an important slide. I want to stress the fact that if you are committed to sustainability, you have to be committed constantly to creation of this factory of the future. We call ourselves the factory of the future. I started this business in 2014 at a corner of SILMO, showing people stuff that, you know, really didn't make sense at that time. But we kind of, you know, invested heavily. In 2016, we created a dedicated factory for eyewear. And today I'm proud here to stand and say that is the factory of the future, because that factory has a zero waste production. Every thing that is made as waste is reused within that factory. It uses biocircular materials as well, and it is ISO 14001 certified, because we continuously invest in reducing our environmental emissions by using green energy, by reducing our water wastage, and most importantly, what we are promoting to the industry is software applications where we can create fully customized glasses, because then we can manufacture only one frame for a certain user. And this is manufacturing down to lot size 1, and we're proud to have put together a factory that today produces, you know, 300,000 frames, of which a significant portion is also customized frames that are produced on demand. Thank you very much for your attention.
Thank you.
If there are any more questions, we're happy to answer.
Yeah, I have another one regarding lenses. What about real sun clear being used for lenses?
So I'm from the 3D printing, but I know that Real Sun Clear is also, they're working on this kind of projects for injection molding.
Yeah, for injection molding, but what about 3D print, using it 3D printing?
I love this question. Transparent powder for 3D printing is something that I think is one of the main topics for each discussion I have. Is we are working on it, but it's, I will be very honest, it will take time.
We do have transparent materials for 3D printing, not in laser sintering. I invite you to go to our booth and see what's upcoming in that domain.